eet105 example problem 1021 for the circuit in figure 10.95 composed of standard values. A, determine the time constant of the circuit. So time constant is tau. It's R times C. R is going to be the total R, so it'll be these two resistors added together as shown here times the 1 microfarad, so it's 5.5 kiloohms times 1 microfarad equals 5.5 milliseconds. Write the mathematical equation for the voltage VC following the closing of the switch. That's this switch, and that would be after t equals 0. Here's the charging up equation. E equals 100 volts. And then the natural number minus t over 5.5 milliseconds. That's the equation. You're not given what t is, so it has to remain a variable. Part C. Determine VC after 1, 3, and 5 time constants. So what you do is, for this t right here, you put in 1 tau for the first part. When you put in 1 tau, you could either put in 5.5 milliseconds, which would make this 5.5 milliseconds divided by 5.5 milliseconds equals an e to the negative 1, or you could just put it in here, put tau in here, and then it, you know what I mean, you don't have to put the number in. You'll get a negative 1 here also if you just put in tau for t. Tau divided by tau is 1, or it's a negative 1, so it would be 100 times the quantity 1 minus e to the minus 1. You have to figure out what that is on your calculator and then multiply it out. Likewise with here, that 3 tau, you would put that in for the little t. You would get minus 3t, minus 3 tau divided by tau. The tau's cancel, and then you get a negative 3 in here, and you multiply it out. Same thing for 5 tau. Now, let's go on to the next part. Part D, write equations for the current IC and the voltage VR2. So IC is going to be this voltage I gave you for the charging of the circuit. When you put that in, this is the equation you get. Again, it doesn't ask you for a specific time, so you just have to leave it written with the time in as shown. VR2 VR2 is going to be a voltage divider, and it's the 3.3k times 100 divided by 3.3k plus 2.2 equals 60 volts. So that's the voltage across there, but then you have to take that and use this equation here. This VR equals E, this equation here. And then it's the voltage across that resistor, normally calculated at full voltage, but then you have to use this equation here to get the full equation for discharge. And then the last part is sketch the waveforms for VC and IC. VC is going to be charging up, and at 5 tau we say that pretty much the capacitor is charged up after 5 time constants. So you're given that tau is 5.5. 5 times 5.5 is 27.5. And then it's going to charge up to 100 volts. So this is all they were looking for that sketch. And then for the current starts off high because it starts off as a short. and it ends up as an open, so it's going to end up at 0 at 5 tau. And when it starts off, you already calculated the current as E over RT, which is 18.18 milliamps.